So the first thing we do with our AppBuilder configuration is go into the General tab and give a name to our configuration. I'm suggesting you call it something like My Switch so that you can call the other one My Light. As long as you have some means to distinguish between the light and the switch, it doesn't matter what you call them. There might be a little bit of delay as you type this, as it's updating some other settings in the background. But once you've set the name, now you can go to the ZCL Clusters tab. In the ZCL Clusters tab, you want to make sure for the switch configuration that you have your device type set to HA on-off switch. Now you can move on to the ZNet Stack tab. And you want to make sure that this application will behave explicitly as a router. Why not coordinator or router? Well, we'll get to that in a minute. The next step is to move to the Printing and CLI tab. So move to that tab, and then you're going to make sure that Enable Debug Printing is checked. And within the clustered debugging section, you can expand that and make sure that you have both checkboxes set for on-off. This is where you're going to turn on printing per cluster. So you're going to make sure that the on-off cluster printing is compiled into the application and turned on by default. Then you're going into the next area and expanding that, and you're going to make sure that you have application, attributes, and ZDO, ZigBee Device Object, checked off for both columns. This will make it easier to see messages related to endpoint service discovery if we find that we need to do that. Now it's safe to move to the How to configure the hardware abstraction layer configuration. For this example, we're going to set the debug level so that we get not only the packet trace information coming from the radio, but some other binary debug data coming from the chip, like reset information, crashes, other critical information, but not API trace data. API trace data is only available in the full debug configuration. Then we're going to set up the bootloader configuration, which we want, in this case, to be standalone. The standalone bootloader was chosen because the application bootloader requires different data flash depending on your hardware, so the example becomes easier to adapt to different boards if you choose the standalone bootloader. Note that if you're following instructions and you happen to have a different board type, don't worry, you can just set the chip type to be something else, but you may end up needing to change some of the GPIO settings when you adapt this to your particular hardware. Now we change the serial settings to change the serial port from the serial 1 setting to the virtually UART serial 0 setting. Why did we do that? Well, not all boards are necessarily accessible on the physical serial port serial 1, but if you set it to serial 0, this emulates a debug port for UART style communication over the serial wire JTAG pins. So as long as you haven't taken those pins away from the debug interface, you should be able to run this example on any hardware, even if the serial configuration doesn't make serial controller 1 available for direct UART access for a command line interface. We're going to select virtual UART for this configuration, and then we're going to move on to the Plugins tab. After selecting the Plugins tab, we're going to scroll down to a section called Network Form and Join. And beneath that, we'll see a plugin called Network Find. So you're going to select that, and within there are a number of options. As per our instructions, we are going to go to the section that says Extended PAN ID, and we're going to change that and enter a fixed set of digits. Why do that? Well, we don't normally do that in real-world applications, but in a training scenario, it makes it much easier to segregate applications based on this extended PAN ID. It ensures that the switch will only join the light that has exactly that extended PAN ID that matches. So that if you have a multitude of lights and switches running these examples, you won't have devices colliding with each other and joining the wrong network simply because those networks are open. If you're running this on your desk by yourself without any other ZigBee networks in your office, without fear of other networks that may be open, then you'll probably be okay without changing this. But since we're emulating what normally goes on in our training scenario, where multiple people run this example simultaneously, we're going to hard code this to some fixed set of digits, such as a birthday, month and day, repeated to fill the 16 digits of the extended PAN ID. And you'll see that once you put in the right number of digits, then you'll see that the field turns from pink back to white again. You can choose whatever 16-digit number you want, as long as that is consistent between the light and the switch configurations that you're going to be doing. Once you've done that, move on to step 7, which is to save this AppBuilder configuration as an ISC file, and you can save it anywhere as long as you remember where you put it so you can recall it for later. Now you're ready to generate, so click the Generate button, and this will take a little bit of time, but after it's done generating these initial sets of files, you'll see a list of files being generated, and the one that you want to take note of here is the IR Embedded Workbench EWW file, which is the workspace for the generated project. So once you've taken note of where that's stored, you can move on to the next step.